Alright, welcome to part 3 of the video that never ends. It's now been 2 hours almost working on this video that won't record. Okay, so we've already talked about graphing exponential functions. It has a horizontal asymptote, and it has this point, and it has this shape that you see. Now, if you take your axis of symmetry for a function and its inverse, if you swap y equals 0 and replace it with x equals 0, you now have a vertical asymptote. Okay, and that also is going to tell us that the point that's at 0, 1 is now going to be at 1, 0. And if you look at the reflection over that axis of symmetry, you can see this red graph that's now about to turn into purple, so you can see me do it, and it will continue on and going forever towards infinity. And it will go down forever towards negative infinity. So what I wanted to do here is talk about the domain and range of each part. If you did the exponential function, the domain's all real numbers, and the range is, the range, is going to be y is greater than 0. Alright, and then the inverse, you're going to have x is greater than or equal to 0, and your range is going to be all reals. Okay, so what that means then is that, and this is why I think you ought to be aware of it, and that is that I cannot take the log of a negative number. And we're going to talk more about that later, but I just wanted to mention that. Now, some people have issues with trying to keep track of the basic shape. Well, honestly, you just need to memorize this now. This is, put it on a card, put it on a piece of paper with the equation on one side, here it is, and then you have the picture on the other side. If you didn't do it in chapter 2, you should have done it. If you didn't do it in chapter 3, you should have done it. And if you didn't do it in chapter 4, by golly, you should have done it. I almost said something else. Anyway, you're just making it harder for yourself. You don't listen to anything that I've been teaching for 40-some years and doing any suggestions because you know better. Sorry. Alright, so you don't have to worry about a proper fraction. You only have to worry about an improper fraction, that is a number greater than 1. Why? I'll explain that next time, next set of examples. But you need to memorize this shape right here. Think it has enough stars yet? Alright, moving on. So, I want to, let's see. No, I'm not going to do the whole thing again. If you were to go to the basic shape you're supposed to memorize, here it is. It's to get a different color. And it has the vertical asymptote at x equals 0, which is the y-axis. And that's your basic shape. So what will a negative do to that basic shape? It rotates it over the x-axis. So instead of getting close to the vertical asymptote in the negative direction, it gets close to the vertical asymptote in the positive direction this way. And it still goes through that same point. Then, well, if this number is in the parentheses, you set the number in the parentheses equal to 0, solve it, and that is a right or left shift, specifically a left shift. And just like with exponentials, the first thing you graph is the vertical asymptote. So that's what I graphed first, is x equals a negative 2. And then I have this point that's 1 unit away, and I draw the same increasing shape, and this increasing shape will get bigger and bigger forever. And it will head towards this, and it will never get close. And what used to irk me about the people that cheated with graphing calculators back in the day when I let them be in the class is they would stop it right there. And the thing's supposed to get closer and closer to the vertical asymptote, and they didn't draw it. They cheated like a dog. Anyway, having to deal with that lately. So when we have a x plus 2 and it's not in the parentheses, this is an upward shift, so this basic shape that used to be at 1, 0 is now at the point 1, 2. So these are the things that happen. These are the basic shifting that go on. And so now I just want to go ahead and show you what to do with graphs. I may erase these and start over, I don't know. Yeah, I think I need to erase some of that. I may leave the correct answer there. Alright, so let's just do this in green. If you had the natural log of x, it's going to be the same basic shape as what we said for you to memorize. The negative is going to flip that over, and so it's going to get smaller forever, but it's going to get close to the vertical asymptote in the positive direction. The x plus 3 is going to cause that graph to shift to the left 3, and it's going to do something like this and get close to the vertical asymptote in that upward direction. Now, what will the minus 2 do to that graph? And the minus 2 will cause that point to shift to this location, and then you see the answer that you see right there in purple that I'm not going to redo since I did such a nice job with the axes. Alright, if it's base 10, that's what this is. It's the same shape as this one. It's no different. Okay, same shape. And so I just did the x plus 4, and that's going to shift it to the right 4, and I draw that vertical asymptote first, and I draw that shape that goes through the point 5, 0. Not that you have to label that, but that's what that point is. And that vertical asymptote is x equals 4. And then I do the plus 1, which is going to cause the graph to shift up 1. So instead of having the point at 5, 0, it's at 5, 1. Not that you have to label that. And there's the shape that you see. So there's your graphing. Whether it's natural log, base 10, or whatever base that I choose, is going to be a whole number or a number bigger than 1. I'm not asking you the other kind. Alright, here's a couple things that I thought of after the fact that I should mention. Okay, and that is, back in chapter 2, I told you didn't have to know this for the test, and I didn't make you know it for the test. But that negative that's underneath the radical causes the graph to rotate. Normally the graph looks like this, but it rotates over the y-axis. That's only special with the certain kinds of functions that are not odd and not even. They're neither even nor odd. And you have a similar situation with this. If you have the log of x with a base of 3, this is what it normally looks like. But because of that negative x, it's going to flip over and do this. I will never ask you these. I'm talking about either of them. This one or this one. Oops, this one or this one, excuse me. In this class. If I see you in pre-calc someday, yeah, I'll ask you, and you need to know it. So you need to recognize that that's what happens. There's a couple in the homework, but I'm never going to ask you about this on a test, or if we had a quiz in class, I would never ask you about it there. Now there's something else about this I want to mention to you, though, before I quit, and that is the domain of a logarithmic function is positive numbers. So can I take the log of a negative 3? So this is what I'm asking. 3 to what power gives me a negative 3? And some people will raise their hand in class and say, so Ash, it's 3 to the negative 1. That's what gives you a negative 3. And they're thinking multiplication. And that's not what the negative exponent means. It means take the reciprocal of the base, and 1/3 is not the same thing as a negative 3. It can't be done because negative 3 is not on that graph. If you look at the graph of the log of x with a base of 3. And the other one that's a common mistake is this, the log of 0. They try to tell me, oh, that's a 1. No, it isn't, because 3 to what power is going to give me a 0? And you tell me 3 to the 0 is going to give you that, and the answer is no. Okay, it's going to give you a 1, so you can't get that. That is impossible. These are undefined. And the reason for that is your vertical asymptote is x equals 0. It's not defined if you remember all our discussion from chapter 3. So the domain of a log function has to be positive. And so go back to the donut time in chapter 2. You can't divide by 0. You cannot take the square root of a negative number. And now you cannot take the log of a 0 or a negative number. Okay, so what can I do? I can take the square root of a 0 or a positive. I can divide by anything but a 0. and I have to take the log of a positive. That's the only things that will work. So that's the domain. And I am done with this thing finally.